You know that the alveolar ventilation is the amount of air that reaches the alveoli for gaseous exchange, while perfusion is the blood flow through the lung capillaries. Now, for lungs to provide the body's tissues with oxygen, the alveolus needs a steady influx of air and an adequate supply of blood. Air provides the oxygen, and blood flowing through surrounding capillaries carries that oxygen to the body's tissues. Now, the ratio between these two, the amount of air reaching the alveoli and the flow of blood through the capillaries, is called the ventilation-perfusion coupling, or ventilation-perfusion ratio. Alveolar ventilation is represented as VA, while perfusion is represented as Q. So, the ratio can be represented as VA by Q. Now, normally, the alveolar ventilation we just calculated, it came out to be about 4,200 milliliters per minute, while the blood flow through the alveoli, or perfusion, is about 5 liters, or 5,000 milliliters per minute. So, putting these values, 4,200 divided by 5,000 came out to be 0.84. Well, it clearly shows that at rest, the ventilation-perfusion ratio is 0.84. So, if the breathing rate, tidal volume, and cardiac output are normal, the VQ ratio, or ventilation-perfusion ratio, is approximately 0.8. This VQ ratio results in an arterial partial pressure of oxygen of 100 millimeters of mercury and an arterial partial pressure of carbon dioxide of 40 millimeters of mercury. Now, optimal function of the lung requires proper balance between ventilation and perfusion. In other words, ideally, ventilation should be matched to blood flow for efficient exchange of gases between the environment and the blood. Hence, VQ ratio in an ideal situation should be 1. If there's a significant change in the ventilation-perfusion ratio, either increase or decrease, it's called ventilation-perfusion mismatch. Ventilation-perfusion ratio is not always perfect. But why is it so? Well, this is because of existence of two factors on either side of alveolar membrane. One of these factors is physiological dead space, which includes wasted air, while the other one is known as physiological shunt, which includes wasted blood. I have explained what I mean by the dead space, but I will get into the details of shunt in a while. Well, variations in ventilation-perfusion ratio can be both physiological and pathological. Taking the physiological variations into consideration first. So, this is how we write ventilation-perfusion ratio. Write alveolar ventilation in the numerator and perfusion in the denominator. Now, we know that if we increase the numerator, the ratio will increase, while, on the other hand, increasing the denominator decreases the overall ratio. So, if the alveolar ventilation increases without any change in blood flow, VQ ratio will increase, while if blood flow increases without any change in ventilation, VQ ratio will decrease. Now, physiological variation also occurs in different parts of lungs. Until now, we have assumed that all alveoli are ventilated and perfused to the same extent. But that's not actually the case. Neither ventilation nor perfusion of the lung is uniform from apex to base. When a person is supine, blood flow is nearly uniform throughout the body, and the lung as well. Normally in standing position, blood pressure in lower extremity of the body is very high, and in upper parts above the level of heart, the pressure is low. But why is it so? Yes. This is because of the effect of gravitational force. Well, a similar condition is observed to some extent in lungs also. Lungs can be divided into 3 distinct zones. The top of the lung, this yellow part, is the zone 1, or what we call apex, or the apical portion. Zone 2 is the middle of the lungs, this part highlighted in green, and the bottom of the lungs is the zone 3, this blue part, also called the base of lung. Now, the ventilation-perfusion ratio is highest at zone 1, normal in zone 2, and lowest in zone 3. But how, is the question. Why the ventilation-perfusion ratio varies in these 3 zones is an important concept here. So, without making a delay, let's jump to the next section to learn about them in detail.
Explore our extensive library of over 1,800 video lectures to learn about a wide range of topics. Only on sqadia.com.